Hello everyone, my name is Cynthia and today we'll be discussing the moving average, MA, and autoregressive, AR processes. So autoregressive processes, otherwise known as AR, use a dependent relationship between observation and some number of lagged observations. So we assume that the current values are dependent on the values that happened before. So we will try to predict something today based off of the past values. There could be some pattern, and we will try to capture that pattern to make a stronger prediction. Now, we will use the PACF to see which time lags are important to use. So the partial autocorrelation function shows the amount of autocorrelation at lag k that is not explained by lower order autocorrelations. So once we plot the PACF, we can see that at lag 1, we have a value that is significant, and by significant we mean anything that is outside of the red bands, so it will be statistically different than 0. So we will want to include that one, and for this model it would be an AR1 since we have a lag at a spike of PACF at lag 1, and that's what we will be using to predict the demand today based on the quantity demanded, and then however many lags ago, in this case 1. Now the moving average process, it's a moving average model that uses past forecast errors in a regression-like model. The value in current day is dependent on the current term and the previous error term. So it will be predicted based off of the moving average baseline plus some coefficient times error from the previous time. A moving average is a series that displays a moving average behavior if it apparently undergoes random shocks whose effects are felt in 2 or more consecutive periods. Now, the MA1 coefficient is minus the fraction of last period's shock that is still felt in the current period. And the MA2 coefficient, if any, is minus the fraction of the shock of 2 periods ago that is still felt in the current period, and so on. Another way to interpret this is that MA1 takes into account the error term from a previous period, and then MA2 will take into account the error term from previous 2 periods. In order to see what MA process we have, or if we have an MA process, we'll look at the autocorrelation function. This plot shows the correlation of the series with itself at different lags. So for this one, we can see on the left side we have an MA1, and that's going to be the ACF for simulated samples. So we see that there's a spike at lag 1, and that's how we get the MA1. We'll be looking at the previous period. However, on the right-hand side, we have an MA2, and the ACF shows 2 spikes that go above that significance level. So we will look at MA2 and then the 2 previous periods to predict the value of it today. Some of the differences between the AR and the MA is that AR uses past values to forecast, while MA uses a moving average model and past errors. Another difference is that MA can be used to fine-tune effects of non-seasonal differences, while the AR is used to compensate the lack of non-seasonal differences. And then MA, if it's negative, ACF at lag 1, and then AR if it's positive, ACF at lag 1. So we'll go ahead and see that at the ACF plot. And then up here, so we see the ACF for AR is going to be positive at lag 1, and then at this one, particularly the one at the top with the ACF, we see that it is an AR and it has 2 spikes in the PACF model. Also for the AR, it's going to have a mean reverting behavior, so we see a slow decay in ACF, and then it will usually be positive at lag 1, as we can see on the top graph, and then there's a sharp cutoff after a few lags in the PACF. Now we will compare this to the MA. So in order to visualize that, we'll look at the ACF, and we can see that it has a sharp cutoff in ACF, and it will usually be negative at lag 1, as we can see on the top chart. And then in the PACF, it'll have a gradually decaying in PACF. And then we also see that this will be an MA1, as we saw before. It'll be 1 spike in ACF. If you would like to research further into this, I would recommend watching the 3rd video and this references. It's going to be the ARIMA models, and that one will show you the importance of the AR and MA models once we combine it to the ARIMA models to make an even more accurate prediction. Also, the time series talk on autoregressive models offers a really great video and explanation on the AR process, and it provides a more tangible example with milk and quantity and something that will be very easy to understand. Thank you for your time and have a great day.